A new store must hire 3 cashiers and 4 stock clerks. So I think what a cashier works at the till, taking in money. The stock clerk is the person who's in charge of putting things on shelves to make sure that, people go for fettuccine noodles, they're there and ready, not out of stock. Okay, so they need 3 new cashiers and 4 new stock clerks, and there's 7 applicants for cashiers and 8 applicants for store clerk. So each of those things is a combination. Because you hire 3 people, doesn't matter the order that you hire them. But this is connected to permutations because the person who is hiring has 2 major decisions to make. They have to hire the cashiers as one decision, and they have to hire the store clerks or the stock clerks as their second decision. Their first decision, there are 7 applicants, they need to choose 3 of them. And their second decision for stock clerks, there are 8 applicants and they need to choose 4 of them. And I have seen this on final exams with an answer that looks like this. And you would have to go from the idea of the question to this. How would you do this? Well, the 7 choose 3. Right? Formula-wise, that would have a 7 factorial on the top, 3 factorial, and the extra number has to add up, 4 factorial, and the 8 choose 4, that would have an 8 factorial and a 4 factorial, and then what adds up to 8 would be another 4 factorial. And then they just put it together as a complete answer. But looking at the answers of the multiple choice, you see something like this, you're like, whoa, that looks confusing. Think about how you go through this question. So sometimes we're going to get combination questions where you have decisions. And you would use your decisions, just like you would use decisions in permutations. I have this many choices for this decision, this many choices for this decision, and there's always multiplication in between decisions. So you would take one and multiply it by the other. And we're going to do actually question of those ones that I just assigned right now. We're going to do question 15, part of it together. So you're going to open that up. And the reason is that some of these are going to be algebraic. And on the exam, they're going to expect you to do them algebraically. Some of them are going to be guess and check. Okay, so when you get to here, okay, some of these are going to be algebraic, some of them are going to be guess and check, and some of them are going to be sort of a combination of guess and check and algebraic. So I'm going to tell you that C and D, when you're solving for the R, you can do a guess and check. For A, which we're going to do together, that would be one that the exam would ask you to do it algebraically and use the formula. So if I'm using the formula for n choose 2, that's n factorial, it would have a 2 factorial, and what adds up to n would be an n minus 2 factorial. So you could get that directly from your formula sheet to plug it in, or you could still use the strategy of, I know on the formula on the top is going to be n factorial, I know there's going to be a 2 factorial, and the bottom 2 have to add up to the top one, and this is equal to 28. Now 2 factorials equal to 2. I'm going to multiply both sides by 2. And what I like to do with factorial questions is I like to get my numbers on one side and my factorials on the other. Because the best way to simplify factorials is to expand the bigger one until you get to the smaller one, and then they'll cancel out. So in this case, between n and n minus 2, n is bigger. So I start expanding the bigger one. n. 1 less would be n minus 1. 1 less would be n minus 2, and when I get to n minus 2, I add the exclamation mark because it would keep going. But I'm going to say this is nice because those both cancel, still equal to 56. And now I have a quadratic equation. N squared minus n, when I multiply that out, if I move the 56 over to make it equal to 0, I can factor. And I get 2 possibilities of answers. N can equal 8 and n can equal -7. But in permutations and combinations questions, when you're solving with factorials, factorials only make sense for positive whole numbers, 0, but not negative numbers. And so if I plugged in -7 here, -7 is wrong because I would have -7 factorial. The answer itself being negative isn't wrong, right? Because here actually +1 wouldn't work either. Can you see if one of your answers was +1? 1 minus 2 would give you a negative factorial. So you do have to plug it in and check that you don't have a negative factorial. And so the only answer here is n equals 8. But in B, this has a mix. B is going to be a mix of algebra and guess and check. Logical guess and check, I'm going to put it. Okay? So here, 4 factorial is 24. If I put my 24 on the other side, I'm just going to write it as multiply 24. There's a reason for that. I don't want to multiply it out because my mental math isn't feeling it this morning. And the reason for this strategy is actually going to be helpful if I don't multiply it out. Now, if I expand the bigger one, I'm going to get n. n minus 1, n minus 2, n minus 3, and then n minus 4 factorial before I can cancel out the bottom. And this side is still 35 times 24. Now, the algebraic method for solving this would actually mean you have to multiply all those out. After you've multiplied them all out, move the 24 over, you're going to have an n to the 4 equation that you would have to use synthetic division, factor theorem, remainder theorem, chapter 1 to factor. And I'm going to tell you it was going to take you a long time. But I'm going to use some logic in this question to solve it instead. The logic I'm going to use is these 4 numbers I'm now just going to replace with spaces. Do you notice that they're consecutive? N, then 1 less, n minus 1, then 1 less, n minus 2, then 1 less, n minus 3. They're consecutive numbers. So I'm going to just replace them with spaces, and on the other side, I'm going to see if I can break up 35 and 24 into 4 numbers multiplied by each other. Okay, right now I have 35 times 24, I have 2 numbers. Can you break up 35 into 2 things? 7 and 5. Okay. 24 you can break up into 2 things, 8 and 3, 12 and 2, 6 and 4. But I want to get 4 numbers in a row. So does it make sense that if I break up the 24 into 6 and 4, that I could rewrite this side as 7 times 6 times 5 times 4, 4 numbers in a row. What's the biggest one? 7. And I just solved this question with a bit of logic and algebra. But it's not algebraic, because algebraic would mean you have to multiply it out, factor it completely, and show that there are no other solutions that work. But for that question, this is the best way to go about doing that.